All right, we've been working with sinusoidal functions, specifically sine and cosine functions, and we've been looking at the translations or transformations, I should say, of those functions. And we've talked about vertical dilations and reflections and horizontal dilations, period, frequency, phase shifts or horizontal translations. And we're going to wrap this up a little bit with a little bit of all of it, but our primary focus here is going to be on vertical translation. So we're asked to state the amplitude, period, frequency, phase shift, and vertical shift of this particular function. And I have graphed these over here that you can see on the screen, and there in the blue is the parent function, the cosine of x. And in red, we have the transformations, which includes 2 times the cosine of x plus 1. Now, we've already learned that this 2 affects the amplitude, how far this thing is going to go from maximum, minimum points back to the midline. And we don't have any phase shifts involved with this, but we do have a vertical translation with this plus 1 sitting out here outside of any parentheses. And our coefficient here of x that might affect the period is, of course, it's just 1. And let's see, I guess before we get to all the stuff we've got to figure out, let's just take a look at what happened here with the graph. Now, in its parent form, the midline is here at the x-axis. And we have, of course, in the parent form, we have an amplitude of 1, but in this case, we got an amplitude of 2, but we also have a vertical shift. And we can see, and I probably can't draw this very straight, but this has shifted our midline up 1. So then our amplitude is 2 above the midline and 2 below the midline. Let's see, we got 1, 2 above the midline, 1, 2 below the midline. So our amplitude, and we'll just put this as A, amplitude equals 2. Let's see, then we're going to do the period. Well, the period is 2 pi over the absolute value of B. But in this case, B is 1, so our period is just equal to 2 pi. And the frequency is the reciprocal of the period. So our frequency in this case is 1 over 2 pi. Let's see what else we got here. Phase shift. There is no horizontal translation in here. There's no phase shift because I don't have this cosine of x, in parentheses, x plus or minus something. So our phase shift is equal to 0. There is no phase shift. And lastly, we've got the vertical shift. Well, we got a vertical shift of, let's call it y equals 1. So we have shifted up the y-axis by 1 unit by virtue of that plus 1 sitting out there. Shifts our midline, and then we can see our amplitude oscillating from that midline. Well, let's look at one other. How about that? All right, so this time, we got a lot more going on this time. Let's see. We got the sine function, 1/2 the sine, in parentheses, x over 4, minus pi over 2, and then -3. Now, I had to change my scale. I usually, most of the time I start with the, I go to Zoom option 7 trig on my calculator. But I did want to make note of what all I did here. Because of this phase shift, or actually, I should say, the difference in my period, really. Because my period here is, or my B value, I should say, excuse me, is just 1 over 4. And when we get to looking at the period, we'll see how that affects that. So I used an x minimum of -pi over 2, an x max of 8 pi, and I used a y scale of pi over 2. So each tick mark there along the horizontal axis is pi over 2. And again, I've graphed the sine function. That's what you see in blue. And then our transformations there in red. And so we see a lot going on. There's a pretty big difference. And since I did a x max of just 8 pi, well, when we talk about the period, I'll address that. So let's see what's happened with our amplitude. Well, I know that I can know my amplitude is this coefficient right here. So my amplitude is equal to 1/2. Now my period, which starts at 2 pi over the absolute value of b, and b in this case is 1/4, and it's positive, so I'm just going to put 1/4. I'm not going to write the absolute value symbols, which that's going to equal 2 pi times 4 over 1, or 8 pi. Now I know in our book it says to graph 2 periods. Well, 2 periods in our transformation is going to be 16 pi. And I opted not to change my x scale out to 16 pi because it would make that parent function look kind of busy. And so what we really see, and you can't see, I think, from my face really, but in my transformation, I only have a period graphed of just one period, 8 pi. Okay, so let's see here. Oh, frequency. Well, my frequency is just the reciprocal of the period, so it's 1/8 pi. And phase shift. Okay, now phase shift is C. It is this value right here over the absolute value. I should put it right here. Let me draw my little circle right here. Over B. So my phase shift, let's try to get over here. Maybe I got a little bit more room. My phase shift is pi over 2 divided by 1/4. And that's going to equal pi over 2 times 4 over 1, which is going to equal 4 pi over 2. But I could reduce that to just 2 pi. So I have a phase shift of 2 pi. And as I've said before, for me, visually seeing that phase shift is often kind of difficult. And so I really rely on that algebraic method to look more for that phase shift. But anyway, there it is, 2 pi. And what is my vertical shift? Well, my vertical shift is equal to -3. And I see that it has shifted my midline down from the x-axis down 3 units. And so I've got a midline running right, just trying to sketch it. It's a poor sketch right along there. And of course I've got an amplitude of 1/2, and so my minimum value to the midline is 1/2. My maximum back down to the midline is 1/2, which of course defines my amplitude. So we've now added vertical translations into our group of transformations of sinusoidal functions, vertical dilations, reflections, horizontal dilations, talking about the period, the frequency, phase shift, which are horizontal translations, all into these sinusoidal functions.